All right. Which of these is linear, which of these is quadratic, and which of these is cubic growth? Okay. What do you think you got to do to this? Let's integrate. So if we integrate this, y, because we got to move the dx first. So y would equal what? 10x squared. What type of growth is this? Quadratic. If we switch this to dx and integrate, what does this become? 20x. What type of growth is this? Linear. Dx. Integrate this. What does this become? 20 thirds x cubed. What type of this? This is cubic. And then this is quartic, because this would be 5x to the fourth. But it doesn't ask that for that. Okay? The rate of change of a perceived stimulus with respect to the measured intensity of the stimulus is inversely proportional to the intensity of the stimulus. Ew. So the rate of change of perceived stimulus, so dp ds is inversely proportional to the intensity of the stimulus. Okay? The rate of change of the perceived stimulus with respect to the intensity, dp ds, equals, and then inversely proportional to the intensity. Okay? Are we good with that? So if it's directly proportional, it would be ks, but inversely is k over s. Which of the following solutions are to this differential equation? How will we go about this? What I would do is find y prime of this. What is y prime of this? Eight cosine of 4x. Because it's 2 cosine of 4x times the first derivative of 4x, which is 4. So 4 times 2 is 8. Okay? What is then y double prime of this? Negative 32 sine of 4x. Okay? If we put those into this equation, negative 32 sine of 4x minus 6 times 8 cosine of 4x plus 8 times 2 sine of 4x, does that equal 0? Well, negative 32 plus 16 is 16, and then that's sines and cosines. Does that make sense? No. So this one will not work there. Okay? So here's y. What's y prime of this? 6e to the 2x. What's y double prime of that? 12e to the 2x. So 12e to the 2x minus 6 times 6e to the 2x plus 8 times 3e to the 2x is 12e to the 2x minus 36e to the 2x plus 24e to the 2x equals 0. 2 works. Let's find the last one. So if y equals ce to the 4x, what is y prime for that one? 4c e to the 4x. What is y double prime for that? 16c e to the 4x. So, is 16c e to the 4x minus 6 times 4c e to the 4x. That's a parenthesis, not a c, and there's a c. Boy, bad penmanship, Mr. Bierschbach. All right, plus 8 times c e to the 4x. So this would be 16 minus 24 is negative 8, plus 8 is 0, right? So it'd be 2 and 3. Okay? Know how to work through those then? Okay. Which of these fits that slope field? Well, 0, 0 is obviously a slope of 0, so it would fit there, it would fit there, it would fit there, it would fit there. It wouldn't fit there, right? Because 0, 0 would be 1 cubed. Yeah. So E is out at 0, 0. Then we go to like 1, 1, and it looks like there's a slope of 1. So that would work there. 1, 1 would have a slope of what here? 0. So B would be out. 1, 1 would have a slope of what? 2. That could have a slope of 2. Might have a slope of 1, might have a slope of 2. We're not sure. So that's still in the running. 1, 1, slope of 2, that might work. Okay? So we got to go somewhere else. Well, see how the slope is 0 right back here? That's got to be a telltale sign of something. So if we go negative 1, 1. So if x is negative 1 and y is 1, do we get 0? No. So that one's eliminated. If x is negative 1 and y is 1, do we get 0? Yes. If x is negative 1 and y is 1, do we get 0? No, we get negative 2 there, right? Process of elimination. You got to look at different places on the slope field, see what's going on. You know, there's a slope of 0, there's a slope of 0. We can kind of figure things out from there. Okay? All right. Another slope field. Which is the right answer for this. Okay? And does also say that the particular solution of 0 is 0. But let's just start working through these and see what it is. Could it be the negative cosine at plus 1? You know, cosine goes like this here, but since this is negative cosine, yeah, it could make a parabolish type thing, and then it could swoop like this where you can't see because it's at, okay, where is the cosine at, where's the cosine 0? Where's cosine equal to 0? At, not at 0, at pi over 2, right? Cosine is 0 is pi over 2. What is pi divided by 2 on your calculator? What's 3.14159 to whatever it is divided by 2? 1.57. So at 1.57, you would think it'd have a slope of 0, but then you're adding 1. So, So the cosine at 0 should be normally 1, but this is negative 1, plus 1 is 0. So it should have a slope of 0 at 0. At 1.57, okay, at 1.57, cosine should have a slope of 0, plus 1 would be 1. So at 1.57, we'd have a slope of 1. Yeah, that could be 1. At negative pi over 2, or negative 1.57, negative pi over 2, the cosine should equal 0, plus 1. Yep. All those would work for there, so we can eliminate cosine. Let's look at e to the x squared. So e to the 0 squared is 1, right? Minus 1 is 0, so that would work. E to the 1 squared. 1 squared is 1. E to the 1 is 2.7182818281828. Minus 1 is 1.71828. That would probably work. E to the negative 1 squared is e to the 1. So you get the same thing. So could be e to the x squared minus 1. That's still in the running. But at negative 1 squared is a positive 1, so I think we're still in the running there. Sine of x. Does this look like the sine curve? Well, at 0, the slope is 0. At 1.57, it's 1. But then at negative 1.57, it should be negative, because the sine curve looks like this. So at negative, it should be a positive slope of 1, not a negative slope of 1. So sine curve should then be out, right? Trust me with that? Because sine curve looks like this. So at negative pi over 2, it's down here where it has a positive slope. And see how this one has a negative slope there. Okay? So we know sine is out. Tangent, do you guys remember the tangent curves? They're kind of like this. Or there's an asymptote here. So if you look at the tangent, it's a positive slope no matter where it goes. So it won't go like that. So that's out. So now we got to decide between these two Hanyackers here. All right. What in the heck? Well, at 0, it should be 0. Well, I think both of them are 0 at 0. Or what is the cosine of 0 is 1. Yeah, they're both 0 at 0. So we got to break this somehow. How about at 2? So what would this be at 2? That would be e to the 4th minus 1. What's e to the 4th power? That's something pretty big, isn't it? (2.7182818281828) to the 4th power would be what? Yeah, like 54 minus 1 would be 53. A slope of 53 would be about a vertical line, right? At 2, it should be a vertical line. Well, it looks like it's flattening back out, kind of like the cosine curve would do. So it must be A. Okay. So you really got to get into some of these a little bit to figure out which slope field is actually the right one. Okay, finding the general solution for this. What's my first step for finding a general solution? Separation of variables. Y dy equals 2x plus 3 dx. Okay, integrate. So if we integrate this, this is 1/2 y squared equals x squared plus 3x plus c. Correct? Guess what? We're not done. Because what do we got to do yet to this equation? Get y alone. Get y alone. So we multiply everything by 2. So y squared equals 2x squared plus 6x plus 2 times c is still c. Now they might say c1 here. They could, on AP, change that to a k instead of a c. Also a constant. Okay? So they might change it to a k. And then take the square root. So y equals plus or minus the square root of 2x squared plus 6x plus c or k, whichever they choose to put in there. Okay? So Remember, there's a plus or minus there. Okay. What would you do on this one to find a general solution? Do dx right away. So dy equals negative CSC squared of x dx. Integrate y equals, what has a derivative of negative cosecant squared? Cotangent of x plus c. Because isn't the first derivative cotangent cosecant squared? Negative cosecant squared? You remember your formulas? Well, I would study your trig derivative formulas. Just a hint. I would know those trig derivative formulas. Yeah. Because you're going to have that. I think you could use your note card. I'll put that in Emily's notes that you guys can use your note card. Did I give you the whole sheet note card or just a little? Did I give you the big sheet? Or you just got a regular note card? No, I gave you the big sheet. The big sheet like that?
You never gave that to us. No. Well, clearly we're given the option to have it because I clear out my folders every year. So this has to be from. Where did you get? You might have been gone.
Maybe you were gone, and I gave you that instead of filling out the note.
Had this as an option for all the
I that's what I thought too. But then with all of you saying I've never seen that before. Yeah, so I'm guessing that I should run that off for everybody. I don't know. Oh well. Know your trig formulas. And yes, you can use your note cards. All right. Particular solution of this guy. First step. Move the dx. So dy equals 4 cosine of x dx. Integrate. Integral of dy is y. What's the integral of 4 cosine of dx? It's 4 sine of x plus c. Well, it says y of pi equals 3. So 3 equals 4 sine of pi plus c. 3 equals 4 times, what's the sine at pi? 0 plus c. So c must equal 3. So the particular solution is y equals 4 sine of x plus 3. Good enough for that? All right. Which of the following differential equations with the initial condition, which one works for this? What would you do? Separation of variables. Y dy equals x squared dx. Integrate. So 1/2 y squared equals 1/3 x cubed plus c. Multiply by 2. Y squared equals 2/3 x cubed plus c. I would go ahead and put in my numbers now before I square root them. And then square root in the end, so you find what c is and then square root. So if you put in a -2 here equals 3 cubed here plus c. So 4 equals 2 times, one of those 3's cancel, 2 times 9 plus c. So c, that's 18, subtract 18, so that's a -14. So 1/2 y squared, actually y squared, because I plugged it in one lower than that. So y squared equals 1/3, 2/3 x cubed minus 14. So if we take the square root of each side, y equals plus or minus the square root of 2/3 x cubed minus 14. Okay, now this has to equal a -2. So if you plug a 3 in, it would have to be e to make the -2. Okay, see why that is? Okay. Student attempts to solve this function. Where did they go wrong? Steps 1, 2, 3, or 4. Step 1, they separated the variables. Did they separate the variables properly? Yep, I think so. Step 2, they integrated. Did they integrate properly? Why not? What did they do wrong? Y has a power of 3, right? So it wouldn't be the ln, it would be y to the -3, so it'd be 1, yeah, it'd be, so y to the -3, y to the -2 with a -1/2, so it'd be 1 over -1 over 2y squared. Should be the integral of that side, right? Bang. Okay. During a decade, the price of silver decreased at a rate that was proportional to the price of silver at the time. So, y equals CE to the KT, right? This is one of those. Okay. The price for the silver was initially at 22. So y equals 22e to the KT. It was $5.50 after 7 years. So 5.5 equals 22e to the k times 7. So let's solve this. And yes, I didn't finish the problem. There should be one more part of this. But, all right. So if we finish this, divide by 22. What's 5.5 divided by 22? It actually works out to be a not horrible number. 0.25. Okay? And then what do we do to each side? ln both sides. So the ln of 0.25 equals 7k divided by 7. So we know k equals the ln of 0.25 over 7, or 1/7 ln of 0.25. So our function equals y equals 22 e to the 1/7 ln of 0.25 times t. That's our function. So let's say find the price at 10 years. Maybe it says find the price at 10 years. So how would we do that? Well, we'll put a 10 in there. So y equals 22e to the 1/7 ln of 0.25 times 10. So if you do that on your calculator, you should get a price. What do you get? Should be lower than 550, because if it was over 550, something went really wrong. $3.04. Okay. So you'll have a couple that are similar to that, where you have to take CE to the KT. Okay. So that's your review. Okay. So Thursday, I'll put in the notes for Emily that if you're really stuck on something, she could try to help you through it. You can use your note cards. And if your note card is a sheet of paper with printed sheet of paper, like Dylan has, that would be fine as well. But there's not really too much you can have on your note card. I mean, so yeah, I'm fine with, or maybe I should take Dylan's sheet of paper and make that everybody's note card, and then have her hand that out out. That might be the best. Maybe. Okay. Maybe we'll do it that way. That way I know that you guys aren't using extra notes on there. So, okay. So there we go.